All right, 1-6 was the last section in chapter 1 before we jump into 2, which we're going to do today. So we talked about inverses. We talked about how to determine if something is 1-to-1, and if it's 1-to-1, then it has an inverse. There was 3 ways to look at it. The coordinate points, like a y couldn't repeat with a different x. The graph, like 1, 2, and 3 here, we used the horizontal line test. And then the equation, like 4 and 5, the x can't be raised to an even power or an absolute value. That's what you're looking for, okay? Notice it says, does the function have an inverse? So we're already even assuming we've done the function test. Pay attention to instructions because it could ask that first. If it wasn't even a function to begin with, you would have wasted time doing your horizontal or your test on the equation. What if it's not even a function to begin with? Okay, so just make sure you pay attention to directions. Because these are functions, I'm going to go straight into the horizontal line test. So does 1 pass your horizontal line test? It does not. Every single point would overlap, right? So this is not 1-to-1. It does not have a function. I'm going to have an inverse. How about 2? Also no. How about 3? Yes. This is the first one that if I wanted to, I could find those coordinate points and then switch the x and the y's. Then you go to the equation. Does 4 have an inverse? No. That x to the 6th is the problem. It can't be raised to an even power if it asked y. And 5? Yes. Okay, the 5th is fine. It's even, that's the problem. Then 6 says to actually go through and find the inverse of the function. So the first thing I'm going to do is make f of x y. Then I'm going to switch my x and y. And then I need to solve for my new y. So I'm going to subtract the 5 and divide by 2. And I'd get y equals x minus 5 over 2. And I have to remember to make that y go to f negative 1. Okay? If you don't change it, I will dock points. You have changed that equation. It no longer is a y anymore. You can, however, leave it together or separate this out. You can make it 1/2 x minus 5/2. So if you were graphing it, you would need to separate it out. If you're not graphing it, then that answer is totally fine, the first one. Questions? All right, so from the homework, this question came up with a couple people actually. How do I graph the inverse of this? So if I'm given coordinate points, then I want to actually take those coordinate points and just switch them. So this would end up being 6, -2, then 0, -1, then -2, 1, and then -3, 4. So what was weird was putting it in this chart. Like -3 should have gone with 4. -2 should have gone with 1. 0 should have gone with -1. And 6 should have gone with -2. You were just completing the pair. And then obviously plot those points and connect them. So you're switching your x and y's. You won't have to fill out a chart should this happen on your quiz. But know that you need to switch those to get the actual graph. Any other questions before we move into chapter 2?
That question, was it okay if you took a screenshot of the graph?
Yeah, totally fine. Yeah. We're good? Yes? Okay, we are starting 2-1 today. There's like 19, 18 slides in this sucker. We are not getting all the way through, okay? We're going to do this between today and tomorrow. This section, or this specific section is like everything you ever thought you wanted to know about a parabola plus some, okay? So we're going to talk about how to take an equation that's not in standard form, put it in standard form. How to take an equation that's not in standard form and graph it using vertex form. How to complete the square is all in this section. And then in the end, how to, if I'm giving you information, find the equation, and also word problems dealing with quadratics. So like all of that is in this one section. Like I said, we're going to do it over the next 2 days.
So homework is due?
Homework we'll do Wednesday. So the beginning of it starts with obviously what a quadratic function. Notice we're saying function, so f of x is there, and we can always sub out f of x and y. Those are the same things. This graph, if it has an x squared, is a parabola. It is shaped like a U. Because they are functions, this would only be a parabola that points up or points down. It can't point sideways. So we're not doing a y squared one. And it's symmetric to a line called the axis of symmetry. This axis of symmetry is going to be an x equals a number. This is an equation. You have to put it in equation form. So now we are getting much more specific than shifting left, right, up, down, okay? These are gonna be much more accurate. This form is called quadratic form. We're gonna go back and forth between quadratic and standard. It's also called vertex form, depending on the book. All right, so the axis of symmetry is this little dashed line that's running vertically through your vertex. It's going to run through the maximum or the minimum point, so that all of those points can be identified from your vertex. The vertex is where your graph changes direction. It is also your maximum or minimum. If your parabola opens downward, it's a max. If it opens upward, it's a min. And again, this is x equals, and at x equals specifically the h, which is the x coordinate of your vertex. So once we find the vertex, x equals whatever the x coordinate is your axis of symmetry. So let's just talk about this first graph, okay? My vertex is at 3, 8. My axis of symmetry would be x equals 3. It is a vertical line that runs through that vertex. So we do x equals h, or x equals the x coordinate of your vertex. What's the vertex of the other one that's there? -1, 0. So my axis of symmetry would be x equals -1. Yeah, make sure you make it an equation. Yep. It has to be a line. You were like, wow, yeah, she's going to do that. Yeah. All right, so how do I know if my parabola opens upward or downward? It is based on whatever's on the front of the x squared term. So that variable is a. If that a is positive, then it opens upward. If it's negative, then it opens downward. It would, again, never go side to side because these are functions. All right, so this one we're going to use based on what we already know, and then you're going to see what happens when this is no longer in standard form. So this is in standard form, which means we can use our transformations, okay? What do you know about this parabola?
It opens upward.
It opens upward. I heard it goes to the left. It goes to the left 1. What's that 2 going to do?
Narrow.
It's going to make it narrow or stretch vertically. Good. So I'm going to go left 1. I'm going to plot my point already. I know that's my vertex. And then instead of just going up and out, I can actually plot some points here to be more specific, but it should be more narrow, okay? If I were to go right and left 1 point, if I did 2 and then I did -2 plus 1 squared, 2, -1 squared, 2 times 1 is 2. So instead of going up 1 and out 1, I'm going up 1 or up 2 and out 1. That's how that vertical stretch is going to impact the graph. I could have done the same thing by plugging in 0, okay? 2 and then 0 plus 1 squared, 2 times 1, which is 2. So again, I know that that's twice the height it normally is. Normally I go up 1, but now I'd multiply it times 2. You just need 3 points, but you need 1 on either side of your vertex so you know how wide or narrow to make it. You can use the symmetry to plot it. So as soon as I knew this was here, I went up 2 and to the left 1. I could go up 2 and to the right 1. And then literally just connect it with your curve. What's the axis of symmetry this time?
Negative.
X equals -1. Good so far. All right, now what happens if it's not? So this is if it's already, that one was given to you in standard form, okay? which is what this looks like. A times x minus h squared plus k. Without even graphing it, you can pull out your information for your vertex. It's the opposite of what follows the x. So I would have changed the sign if you go back to what we just did. No, that wasn't what it was. Sorry, hang on. It was to the left too, right? So it was plus. Was it left? Okay. It looked like this, right? There would have been no k, which is why your y was 0. And the vertex was left 1 and up or down not at all. So that would have been the same thing as taking it out of your equation. You would change the sign of what follows the x. You would leave the sign of the k, even if it wasn't 0. And then the axis of symmetry, again, would have been x equals -1. So I can do it without graphing it is the point here. And again, this is standard form. We're going to go back and forth between those terms. Standard form, you don't have an x and an x squared. That's how you know the difference. You just have either an x squared or you have the parentheses squared, but not both. All right, if I'm given it in standard form, then I'm going to kind of just put it together with what we almost did just a minute ago. Determine if the parabola opens up or down. So positive A is upward, negative A is downward. I'm going to find the vertex, which is that HK. And then it's probably going to ask you for intercepts, so you might as well move there next. For the x-intercepts, we're going to plug 0 in for y. For the y-intercepts, we're going to plug 0 in for x. And then if that's enough information to get 3 points, then I can plot those points, draw my parabola, and be done with it. If it's not, because there are going to be times in which you don't have x-intercepts or you don't have a y-intercept, well, you could have a y-intercept, but it would be huge. Okay, that could happen, or really small. Then I would plot additional points to the left or the right of your vertex, whatever is needed to make sure that you draw your graph accurately. You need 3 points. The vertex, 1 on the left of it, and 1 on the right of it. All right, put it together. First of all, it's in standard form. I know this because there's not an x squared and an x, okay? So based on standard form, I'm going to look at my graph, or look at my equation and pull the information out. Which way does this face? This face is down, okay? What's my vertex? -2, 4. I'm going left 2, up 4. So already I can do that. -2, 4, and I know it's going to point down. I need more points to figure out how wide or narrow. Now if it said find your intercepts, I'll do the x-intercepts by making y, which is where the f of x is, 0. So first thing I'm going to do is subtract the 4. I get -4 equals -x plus 2 squared. I have to get rid of the negative on the front. So I could divide or multiply by -1, doesn't matter which one, but it's got to go away. I get 4 equals x plus 2 squared. Now what? How do I get rid of the squared? Square root. When I square root both sides, what do you have to remember to do? Plus and minus. So that means x plus 2 not only equals +2, but it also equals -2. And this is where I end up with 2 intercepts. -2 equals x plus 2, and +2 equals x plus 2. Subtract the 2, x equals -4. Subtract the 2, x equals 0. So I have 0, 0, and I have -4, 0. Plot those on your graph, 0, 0, and -4, 0, and it's consistent with a parabola that points down. So already I have 3 points. I can make my curve. Now, what's your y-intercept? 0, okay? You already have it from the x, but it's not always going to happen that way. So if I didn't have it from the x, how do I find a y-intercept? Plug 0 in for x. I'd get y equals negative 0 plus 2 squared plus 4. Y would equal, I do inside the parentheses first, so I'd get negative 2 squared. I then square the 2, I get negative 4 plus 4, which is 0. And it's consistent with what we found, which is that our y-intercept and x-intercepts overlapped because they were both 0, 0. What's the axis symmetry? X equals negative 2. What's your domain? All real numbers, negative infinity to positive infinity. What's your range? Negative infinity to positive 4 with a bracket on the 4. What's your increasing? Negative infinity. Ooh, that's what got you on the test. To what? To negative 2. What's your decreasing? Negative 2 to positive infinity. Remember, increasing and decreasing is your x values. Questions? I will. I'll wait. You're welcome. All right, what direction does this face? Up. What's your vertex? Good. What's your axis of symmetry? X equals 3. Good. Okay, so 3, negative 4 already here, and I know it's going to point up. So because it's going to point up, I expect to have 2 x-intercepts, right? The benefit of knowing direction already is if this points down, what happens to my x-intercepts? God bless you. There is none, right? So when I go to solve that, I actually get something where I'm square rooting a negative number. That's how that will show up, okay? They wouldn't exist. But the fact that I know this points up means I'm going to get 2 x-intercepts, okay? So if I were to do x-intercept first, 0 equals x minus 3 squared minus 4. Add the 4. Square root both sides. I'd get plus and minus 2. Negative 2 equals x minus 3. Positive 2 equals x minus 3. X equals 1 and x equals 5. So 1, 0, 5, 0. Which is consistent and symmetric, right? So that should also make sense. Connect these, okay? What do I know about the y-intercept? Is there one? Yes, it's probably off my graph if I'm kind of like consistent, right? So if I do that, I'm going to plug the 0 in for the x. Negative 3 squared minus 4 is 9 minus 4, which is 5. So it's going to happen up here. If you want to go out in the opposite direction to make it symmetric, you totally can, but you don't have to. Questions? If your y-intercept is huge, like, I don't know, whatever, it's 27, you literally could just plot the point, and this is going to happen on your graph. Your graph is not going to be beautiful for like a quiz or whatever. If it's 27, you could literally do 0, 27 and draw yourself the arrow, and that's good enough for me, okay? I don't need it to be at that point. I don't need you to draw 27 little tick marks to get where you need to go. All right, so now what happens if it doesn't give it to you in standard form? What happens if it gives it to you in what's called either quadratic form or vertex form? They call it kind of both, okay? If it's not in that form, then you really have 2 choices. One is put it into that form, and that's what this process is called, which is completing the square. Tomorrow, we're going to talk about the other option, like what do I do if I want to just keep it in this, and that's the negative b over 2a, if you remember that. That we'll do tomorrow. For now, we're going to force it into standard form by doing complete the square. Here are the steps to complete the square. We are going to group the ax and the b, or ax squared and the bx together. So if I had a number I would group these together. We're going to leave a space because we're going to fill that in, and we're going to put the C on the outside. Remember this? Yeah, so fun. If there's an A other than 1, we're going to take it out, whether that's a negative or it's an actual value. We're going to take it out, and by taking it out, we take it off of both these terms. It would change the signs if it was a negative. We'd have to divide by the number if it was something other than 1. Then you're going to take the second term, whatever's left, divide it by 2 and square it. So it'd be b divided by 2 squared. And that's what you're going to add inside the parentheses. And we're keeping this all on one side, so we're going to have to subtract it from outside the parentheses. We're going to walk through this process a couple of times, but this is just a quick review. And then you're fine. Then you're going to actually, in between here, you're going to factor your perfect square, which is what you just made. And to do that, we square root the first term, we square root the last term, we take the sign from the middle, and we put the square. And then whatever's on the outside is going to get carried down here. So you are forcing it into standard form by doing a process called complete the square. If you know you don't remember jack about complete the square, remember there's those prereq things at the top of the module. It's there too, and it has videos and extra practice on complete the square. We are obviously going to go through it a couple times, but we're not going to devote days to it like you did in Algebra 2. So if you need a refresher more than today and tomorrow on complete the square, that's where you'll find that supplemental stuff. It is there, but you got to get it, okay? And obviously I can help you with it, but we're not going to spend, like we spend days on this in Algebra 2. We're not doing that here. All right, so notice the change in instructions. It says write the function in standard form, then identify the vertex, the symmetry, the x-intercepts, and all that stuff. So we are doing the work first on completing the square. We're going to take what's here, and we're going to put it into standard form. So you can change f of x to y if you want to, and you don't need to. I'm going to first group together these first two terms. So x squared minus 14x, and I'm bumping the 54 to the outside. We're baby stepping our way into the ugly ones. There's nothing on the front of the x squared this time. If there was, I'd have to factor it out. Now I take that negative 14. I'm going to ignore the sign because when you square it, it goes away anyways. I'm going to divide it by 2 and square it. So I get 7 squared, which is 49. I'm going to add that inside the parentheses. And because we're keeping this all on one side of our equation, I have to balance it out by subtracting it from what's on the outside. When we did these in Algebra 2, you were solving this equation, so there was a 0 on the other side, and we added to both sides. That's not the case here. We're keeping it all on one side, so that's why we're adding inside and subtracting from the outside. All right, now I made it a perfect square so I could factor it. I square root x squared, which is x. I square root 49, which is 7. I take the sign from the middle term, which is negative. Put it in those parentheses, square it. And then positive 54 minus 49 is positive 5. This is now in standard form. Now tell me what you know about this parabola.
So vertex is 7, 5.
Vertex is 7, 5.
And the AOS is x equals positive 7.
Good. Axis symmetry is x equals 7. What direction does it face? Up. So start there. 7, 5. It's going to point up. What does that tell you about your x-intercepts? There are none. we're gonna check because I want you to see what happens, what it looks like when there's none. So I'm gonna say 0 equals x minus 7 squared plus 5. God bless you. You're welcome. I'm gonna subtract the 5. And then I have to square root both sides. And what happens when I go to square root the negative 5? Doesn't exist. It's an imaginary number, and that's why there are no x-intercepts. With me so far? Yeah? Okay, y-intercept. I'm going to plug 0 in for x. And I get 49 plus 5, which is 54. Where else do you see a 54? The very beginning. Was it going to be easier to find the y-intercept from there or from what we just did? Why? Why is it so easy from the beginning? It literally is just the c.
That's always going to happen.
Always going to happen if it's in quadratic form at the beginning. So you do not need to. I would go back to the beginning and find the y-intercept from there. Okay, so obviously I'm not plotting 0 and 54, okay? It's going to be off your graph, which means I need 2 additional points, okay? Because there's no vertical stretch or horizontal stretch, I could literally go up and out 1 in either direction to make my parabola. What happens if you're unsure? What could you do? I could plug in some extra points. I would literally plug in 1 from the left of my vertex, which would be 6 in this case, 1 to the right of my vertex, which would be 8. And they should both give you the same value if your graph is right. Questions? I think. All right. So before we get to even all of this, we're going to put this into standard form. All right. So what's different about it this time? Why am I making you do this? There's a negative there. So this time when I group it, there's something attached to the x squared. The same exact thing is going to happen if it was a number. It doesn't have to be negative. It could be a positive 2 there. If there is anything attached to that x squared, you have to take it out. So I factor out the negative, and by factoring out, I divide it into both of those terms, which means it's going to change the signs on both of them. So this becomes a positive 3x. So not only does it impact that, like whatever I took out, I have to divide by it, but it's also going to impact what I do when I add and subtract. So I'm going to first find this one. I take the 3, I divide it by 2, I square it. I'm going to keep it as a fraction. So this would be 9/4. I add 9/4. What do you normally do on the outside? Subtract 9/4. Here's the catch. If you take something out, you have to multiply it by whatever you're subtracting before you actually combine it. So by multiplying it by -1, what happens? It changes it to plus 9/4. So negative, I'm going to factor it out, negative x. Square root of 9/4 is 3/2. It's what it was before I squared it over here. Take the sign from the middle, put it in parentheses and square it. And then I want to add these two. So 7/1 plus 9/4 becomes 28/4 plus 9/4, or 37/4. Now what's your vertex? Good. So tomorrow, I'm going to stop here, and tomorrow we'll go over what to do, the other method, which is the negative b over 2a. Listen to me carefully. Every single question on that web assigned, well, not every single one, but every single graphing one at the beginning says put it into standard form. So go through and do complete the square part of this. Put it into standard form, okay? You don't have to complete every single question tonight, but if you save it all for tomorrow, you're going to hate life. So at least do that part. Put it into standard form and then graph a few. Tomorrow, I would say even wait because don't do all of it because we're going to do the other method, which is that negative b over 2a method, okay? You are going to get quizzed on both though, so it's important that you know how to put it into standard form using complete the square and then also use the negative b over 2a to find the vertex and that kind of stuff.